Do it. All right, welcome back, physicists, we'll call you. Today, we got to start the last section of Chapter 5, which, man, it almost is as if it coincides perfectly with a singular test next week that'll cover 2 chapters, like we discussed.
Would that be our final, or is your final test?
Yes.
Would that be the final?
Yeah, it's going to be our final.
Is it open now?
No. Yep. We are going to have our test. You guys leave what day? And let's see. Finals in here is Tuesday, Wednesday, Thursday is when it works. So did you guys ever take finals in middle school?
Yeah.
Like real finals?
Yeah.
How does it work?
2 hours for each period.
Okay. Yep. So I think Monday's a normal day. I think.
Yeah.
Yep. Monday's a normal day. Tuesday, you will have finals in first and second hour. And then after lunch, those are 2-hour blocks that day. After lunch, you go to third and fourth. Am I already recording? Weird. Wednesday, you'll go to third and fourth hour right away in the morning. And then you'll have fifth and sixth hour after lunch. And then on Thursday, you'll go to fifth and sixth hour in the morning. And then you'll have after lunch first and second, which is always weird because you've already done the finals there. Wrestlers, we're going to have to find time to get you in here before Thursday because you won't be here Thursday.
It's just Mr. Russell said we're gonna do on Tuesday. Well,
Tuesday after school?
yeah.
For all of your finals?
Yeah.
That seems kind of heavy.
Well, what he said.
Well,
We'll talk. We'll discuss it without everybody because we don't need everybody. All right. So today we are going to start the discussion of how does one go about using thermal energy. And a lot of this stuff, I think I am often guilty of assuming that you guys know more about stuff than you do. Which, my bad. Like, it's obviously my job to teach you stuff. When and if I talk about stuff and it sounds like I'm assuming you all know what it is, but nobody has any idea, what do you do? Yes, please tell me. Interrupt me as soon as possible because I don't want to make assumptions that leave gaps in your knowledge, right? Okay, so looking at it, we are going to start using and seeing how we use thermal energy. And there's a lot of stuff that goes into like real life applied stuff within these ideas. So our first little topic that we're going to cover is heating systems. All right. Now, most of the U.S., most of the United States, most houses, like houses need heat. Where in the U.S. might that not be the case? So in California, depending on where in California, if you're in like Southern California, maybe you don't really need a heater in your house. Arizona, like if you're in Phoenix, which we all agree is the worst place on earth, then you probably don't need a heater in your house. Do you need a heater here? Yeah, but what don't we need here? You don't need AC. How many of you guys have spent a significant amount of time in Seattle? Okay, when you're in Seattle, do the places that you're at have air conditioners? Some of them do, right? Like old residential places, though, pretty common in Seattle that people don't have it. When they get a heat wave in Seattle, what's hot in Seattle?
90.
90 would be screaming hot in Seattle. When it gets 90 degrees in Seattle, people literally die because of the heat. Yeah, if you get elderly people or people who live in the upstairs of apartments that don't have ways to cool down, 90 degrees constantly is enough for people to succumb to heat stroke and stuff. Now,
what's like a hot day to you where like you don't need a sweater or anything? Like just it's just perfect.
it depends, like here.
Yeah, or like anywhere.
So it varies because if I'm here, like 65 degrees is perfect for me. I'd probably wear shorts and no sweater on a 65-degree day here. But if I went from here down to South Dakota, where I'm from, for like a week, 65 degrees after a week there, after I'm acclimated, would be like pants and a light jacket weather. Like it just depends on your sense of normalcy that you're in. Does that make sense? Do you guys feel the same way about that?
You know what's weird?
No?
I don't. This is not really important, but you know where Barrow is, right?
I do.
When I went up to Barrow, it was like it wasn't like the ocean was frozen over and stuff, but we were all hot up there. Like we wouldn't wear jackets outside, and yeah. it was
Weird.
rough. Like we didn't. Yeah.
That is really weird.
Seriously, like we wore hoodies and stuff, but sometimes we would take them off because we were like warm enough out there. It wasn't even cold.
Interesting. I wonder why.
In the summer, but in the winter.
Oh,
it's
well.
like- but still, it gets.
Chilly. Oh, for sure. I'll tell you, I'm just gonna bash Phoenix all the time because I hate Phoenix. If you ever go to Phoenix, it's so bizarre. Like in the middle of summer, it's super hot all the time, and good thing that they live in a place that's easy to cool and there's good access to water and all that stuff. When you go inside buildings in Phoenix, you still, in the middle of summer when it's like 110 outside, you still carry like hoodies and stuff around with you because they run the air conditioners and they keep the buildings at like 70 degrees, which seems pretty comfortable, but it's so unbelievably cold if you're walking into a 70-degree room and it's 112 outside. Like, it's crazy. If you look at teachers and like stuff in Phoenix, they dress just like me, even though it's crazy hot because it gets so cold by comparison. It's that contrast that we feel. So let's talk about this and we'll come back. Now, in our country, most places need heat. So we're just going to make that comment. Most U.S. homes have heat. And I'm talking specifically heating systems that we're using. And I'm going to say have heating, apparently, because that's what I wrote. What types of heat do you think people in this country use primarily? Like, what do we use here?
What do you mean, like diesel heater?
So we might use a few different things. So there's propane, which I don't know why I'm asterisking here again, but check it out. We use propane, certainly. What else do we use here?
Solar energy.
How many solar panels do you see while we drive around?
One.
Where?
Right by my house. Right
Okay. So I'm going to put a question mark next to it.
Electric.
So be careful, though, because solar isn't really the heat, but what I think it was Henning, I didn't see. What the electric heaters, like that's would be powered by solar. How do most of your homes or apartments here probably aren't heated by propane?
Radiator?
So radiators could be propane. When you say oil, what do you mean?
Who's it on?
I don't know. Somebody said oil. What sort of oil? Okay, I'm good with that. Fuel oil is a common name for it. Fuel oil, and this is just diesel, is what we use here. Okay. Any other places you can think of? Or any other? I'm sorry. Any other types of heating that we use?
Open fire?
Ooh, wood burning.
Yeah.
Okay.
Oh, coal burning.
So those are more rare, but definitely. Most homes these days aren't made with a coal burning furnace, but they do exist. And they're crazy because when you fire up a coal burning furnace, like it's a big piece of metal, obviously, it's a big piece of steel, they glow red hot. Like they get hot enough that they're literally glowing as if they're about to start melting. It's crazy how hot they can get. Any other ways or types of heat that we produce here? The sun, I would call that solar, and we will talk about it more specifically, but you're right. I'm not going to write the sun again because we already wrote solar. The last one, these are not as common, but we do use these things called heat pumps. We don't use them a ton here, but they do exist. Cool. So most U.S. homes get this. Now, in every situation with the exception of one, we're not ever creating energy, right? We cannot do that. What do we do with energy?
We use it.
So you're right.
Transfer it?
Transfer or change it is all that we're doing. And every single one of these, every single one of them relies on what?
Energy. Or
Still.
Do they have a fuel of some sort?
Yeah.
With the exception of solar, which it does have a fuel. It's called sunlight, but that's a weird one to think about. All of these can be summed up pretty easily. These all convert chemical energy in some form or another into what? When I'm heating my house, I'm burning diesel or propane, whatever it is, to produce what?
Heat. Thermal?
Heat, thermal energy specifically. The heat is that transfer, but we're just going to say into thermal energy. Every single one of these, and I would make the claim that even solar is a chemical reaction that then converts it into thermal energy. So looking at these, we don't have to go like super crazy into them, but it's nice, especially if you're not going to live here your entire life, or maybe if you are, that's also fine. This will still apply. Where I'm from, I'll tell you, the floor, the baseboard heat isn't common. That's not what I used growing up. I'm from South Dakota. there were two main things that we used where I'm from. If you had a newer house, you had what's called a forced air system, which, does anybody have like vents on the wall that blow air out? Like hot air here? They're pretty rare. If you have a Toyo stove, it's like that, but it's in the walls.
Are you talking about the circle vents that
They could be circular. Uh,
all the native houses here have those, the ones underwater.
These sorts of things, either on the floor or on the walls. Whoa.
Oh, I've got you have one on your floor, right?
And hot air comes out? Okay, cool. So what you're seeing there in that situation, that's one type of heating system that's really common in our country. These are forced air heaters. Now,
Oh yeah.
they can if you have rats in your walls, because there's ductwork, which is just those metal squares that are really not as big as you can crawl through, like it makes it look in movies. They're not that big, just so you know. Don't crawl into air vents. But forced air, they're really common. Doesn't matter. If you have a Toyo stove at home, somebody does. I'm almost sure of it. Who has a Toyo? It is a brand, Toyotomi stove. One of these. So that's a Toyo stove. These are diesel burning. You can also get these. I mean, I do. Yep, so you have one of these then, probably. Interesting. So Toyotomi is the company that makes the Toyo stove, or heater, if you will. They burn diesel fuel. Rinnai is another company that makes these. These burn propane. They both burn something to produce thermal energy. Now, the basic setup of these, and those ones are more fancy than we typically get, but we're just going to look at the basic setup of a few different ones. So a forced air heater. I'm just going to draw a picture. And I want you guys to draw a picture with me. Okay, check it out. You have, off to the side, a furnace. Okay, doesn't matter. It could burn propane, it could burn diesel, it could burn coal. Doesn't matter what it burns right now. Okay, in here, what you have is you have two pipes that connect to it. So here's our furnace. We have an inlet right here. In. I'm going to put an arrow going in. I'm going to wrap this thing around because we're not going to draw a three-dimensional house. I'm not going to. You can if you want to. Okay, so we get air coming in. And if we're going to connect this to our house, I want to think about where should we put this. Here's our lovely house, again with that kind of modern, fancy roof style, or terrible, I don't know. There's a house. Neat. Where would you connect the inline, the air that goes into the furnace? Where should I connect this to my house? Why the bottom? I agree.
The ground.
Say it again?
The ground. Like the ground. So the heat rises.
Oh, if you're going to use a furnace to heat stuff up, do you really want to pull in all the hot air from your house to then heat up to blow hot air back into your house to get sucked back into the... Like, that's just a waste of money, right? We put it on the floor because what sort of air is there?
Cold air.
Cold air goes in. Cool. Inside this furnace, regardless of what it is, these are purple flames this time. They get hot. They get hot. Air passes through that in a tube around really hot fire. What happens to the air in that tube? It gets hot. We then have another hose coming out here with a fan that pushes air this way. Where should we have this? You want this on the roof? It's a fan, I'm sorry. This is a fan. Why is this a bad idea?
Is it still connected to the furnace?
Yep, they both connect. One brings air in, the other takes air out.
I think you should put it on the other side of the house.
So it can be on the other side of the house, but I have more of an issue with where it's located. We should probably blow all the hot air to the floor so that it'll rise up, and then all the cold air that we get afterward is still just down at the bottom, right? Because hot air is going to go up. Yeah, exactly. So we're going to take that. We're going to move it all the way down here. Now, Sonny, you're absolutely right. Typically, they're not right next to each other because that'd be silly. What will normally happen if a house is designed well is somebody will come in and say, well, based on the structure of this house, here's where I expect the cold air to pool, right? Something of that. You would put your inlet valve or vent there to suck in that cold air. It goes through after it burns. It heats up, blows through a fan. And now look at this. You get a nice hot house. Cool. Variations of these exist. And I would argue that a Toyo stove is a variation of this. Depending on where this is there any risk to you as a person in your home if you have your furnace inside?
Yeah.
What's the risk, do you think?
Burning down.
So, one, you could burn down your house. That's definitely a scary risk. What is that? It could explode. It's pretty rare that they do because they have a lot of safety features in them. One more thing that we often don't think about. If something's burning, can you smell it?
No.
Yes.
Well, yes.
Yeah. Was it this class that we talked about carbon dioxide in here the other day?
No.
Oh, okay. You guys have held your breath at some point in time.
Yeah.
What is it that, like, if you hold your breath, I don't know how long you can hold your breath. I'm not going to make you hold your breath right now. But I don't believe you. At the end of it, you can feel very clearly you need to take a breath, right? What's happening in your body that tells you need to take a breath?
Your brain. What?
Your muscles.
It is. So it's the carbon dioxide in your blood. It's not a lack of oxygen that your body recognizes. Your body doesn't have a way to tell if it has oxygen in it. What your body recognizes is if there's too much CO2. Okay. CO2 is dangerous. It's a byproduct of burning stuff. There's another more dangerous byproduct of burning stuff, though. CO, or carbon monoxide. If CO2 is present, you're probably going to be able to smell the smoke or something. Why are you guys going like a minute and a half early still?
Just packing out.
Well, yeah, I noticed that. That's what I'm commenting on. Okay, for this, we'll continue tomorrow. That derailed me. That was also really annoying, just so you guys know. But that derailed me. We'll see you cool cats and kids tomorrow. You get like 30 seconds to your own. Cool.